Imagine a mountain so high it wears the clouds like a crown. And once every 10,000 years, a solitary bird returns carrying a single feather in its beak. Flies the old circuit, never heard, never seen by the eyes of men. Over the summits, the feather nestled gently in its beak, and with the smallest, most deliberate motion, it draws the feather across the stone. The touch is almost nothing. A whisper of creatine on granite. Seasons unravel between those visits. Glaciers sigh. Forests rise, migrate, and vanish. Rivers redraw continents. The feather's arc, repeated 1,000 times, becomes a force more patient than storms. And when at last the peak is smoothed to the memory, when the feather rests upon what remains, then and only then has a single silver of eternity slipped past. Eternity is not a roar. It is the bird that remembers, the feather that keeps its promise, and the slow, faithful wearing of stone. Imagine the bird, imagine the feather, imagine forever. Now, how long would this actually take? In this episode, we find out. My name is Fredrik Sträng. I'm your host. This series explores adventures, science, philosophy, and the questions that live between them. If you enjoy this kind of content, please subscribe, like, and share. It genuinely helps. Human beings are terrible at understanding time. Not hours, not years, but deep time. Our brains evolved to track season, not eons. 10,000 years already feels abstract. A million years feels fictional. A billion years feels meaningless. And yet that is the timescale on which reality operates. Mountains are not permanent. They're events, slow ones. The Himalayas themselves, the tallest mountain on Earth, are still rising. India is still colliding with Asia. The crust is still folding. Everest grows by a millimeter each year. But erosion is always there. Wind, water, ice, gravity, and eventually time wins. The feather is simply a metaphor for how absurdly patient time really is. This idea did not come from nowhere. Its deepest roots lies in Buddhist philosophy. In the Pabata Sutta, the Buddha describes an eon, a kalpa, by comparing it to a massive rock mountain being worn away by an impossibly slight action, repeated over inconceivable spans of time. In some versions, a man brushes the mountain with a fine cloth once every 100 years. Later, modern retellings reshape the image. A crow, a silk scarf, a feather. The most famous phrasing appears in 1981 novel by Louis Duncan, where the metaphor becomes a cinematic, a bird, a mountain, a mile high, a feather every 10,000 years. Different tellings, same message. Even when the mountain is gone, eternity has barely begun. But poetry invites a dangerous temptation. We feel it, but we don't test it. So let's do what we've done before. Let's ask a mathematician. Let's ask a physics teacher. Let's turn metaphor into numbers, because the Himalayas are not imaginary. They have mass, density, surface hardness. Granite wears at measurable rates. So let's define the problem. Assume the boundaries of the Himalayas and its volume. There is no single official boundary of the Himalayas, so for this calculation, we adopt the standard geomorphological definition. From the Indus River in the west to the Brahmaputra Gorge in the east, and from the main frontal thrust in the south to the edge of the Tibetan Plateau in the north. Now we have to ask what the Himalaya is actually made of. By volume, the Himalayas is almost entirely rock. Glacier ice is the thin reservoir, measured in thousands of cubic kilometers, while the mountain's bulk is measured in millions. Seasonal snow effectively zero in total volume budget. In rough but defensible terms, that means rock makes up approximately 99.5% of the total volume. Glacier ice accounts for roughly 0.5%. Seasonal snow contributes far less than 0.01%. Negligible at this scale. So when we talk about erasing the Himalaya, we're not talking about snow. We're not even really talking about ice. We're talking about stone. Then we assume a feather brushing the surface once every 10,000 years. Each pass removes an almost immeasurable amount of material, far less than erosion by wind or ice. Even if the feather removes 1 micron of rock per pass, which is wildly generous, that is 1 micron every 10,000 years, 1 millimeter every 10 million years, 1 meter every 10 billion years. At that rate, to raise 1 kilometer of mountain would take 10 trillion years. The universe itself is only 13.8 billion years old. The Himalayas would outlive stars, outlive galaxies, outlive the sun, and even that time would still be almost nothing when measured against eternity.
So what do we need to know to be able to figure out how long time it would take for a feather to erode or flatten down the Himalayas? How much matter will this feather erode from a rock? But each time it passes, it's 10,000 years actually. If we approximate 1 microgram, that is 10 to the power of minus 9 kilograms. It's a very, very small amount of matter. So the feather will do that to the rock. The rock is the Himalayas. And the Himalayas, if we would make a sketch of it, would be something like a mountain and with some tops here, and then we would have some tops higher up. A big mountain massive. From a top view, if we use a computer program, a GIS program, we could find the area that the Himalayas cover. And there we have had a number of 595,000 square kilometers would be the area if we would look upon the Himalayas something like this from the top. This is the area of the Himalayas. And as you can see in my drawing here, Himalaya has some peaks, some highest peaks, what is between 8 and 9 kilometers height, and we have a lot of peaks from about 4 to 6 kilometers, and we also have a baseline of the Himalayas on about 1 kilometers. And why are we talking about all these numbers, the area and the heights? Well, we want to find out finally how much mass, how many kilograms of rock is there in the Himalayas. And then we need to know the volume of the Himalayas. And because of the different heights, if we would take this mountain formation and press it down into a block, where we would flatten down the highest tops into the valleys and make it all a solid block of rock. What would then be the medium height from the bottom to the top, if we have flattened it down as much as we can? That we can approximate to 3.5 kilometers. And now then, we want to know the volume of the Himalayas. That is done for a block. If you remember that, we take the base area times the height of the block. So volume is area times height. And then we have 5.95 10 to the power of 5 times 3.5. And then we will have 2.08 times 6 cubic kilometers. Now we have a number of the total volume of the Himalayas. This we need to use to be able to calculate how big mass, what is the weight of the Himalayas. And for that, we need to use a concept called density. It has this Greek symbol, rho, and that is equal to mass divided by volume. This you use when you have the volume. You can use this concept to calculate how many kilograms will we have from a certain volume. For rock, 1 square meters of rock would have a weight of 2.5 ton per square meters, would be 2,700 kilograms per square meter. So now we know that the Himalayas have a volume of 2.08 times 10 to the power of 15 cubic meters. And we also have a figure of the density for normal rock, which is 2,700 kilograms per cubic meter. And before we can do anything with the fact that we know we take 1 microgram each 10,000 a year, we need to find the mass of how much weight has the whole Himalayas. And that is equal to the density times the volume. And then we will have 2,700 times 2.08 10 to the power of 15 kilograms. And what is this? 5.62 10 to the power of 18 kilograms. That is the mass or the weight of the entire Himalayas. As a comparison to the whole weight of the whole Earth, that is actually just a billionth part of the mass of the whole Earth. This is only 1 billionth part of that mass. But it is in the same size as the weight of the entire atmosphere of the whole Earth. But now then, the final interesting question is, with a feather taking away 10 to the power of minus 9 kilograms each 10,000 years, how long time would it take them to erode the entire Himalayas? We know that the feather is taking away mass eroding rate, to say like that, is 1 microgram each 10,000 years. That is the speed of how fast the feather is taking away mass from the entire Himalayas. So if we divide the entire mass, 5.62 10 times 18 divided by 1 microgram or 10 up to minus 9 kilograms divided by 10,000. What figure would we then have? 5.6 times 10 to the power of 30. Yes. That is quite a big number. If you would write it with zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, so many years. So we will have some numbers to compare this number to get some perspective. For example, our universe is 1.4 times 10 to the power of 10 years old. And that means we are somewhere here. And Himalayas can then stand quite much longer than the whole entire universe have existed so far. We have some other numbers. For example, we have the proton. The proton has actually, they have estimated an approximately life length of 10 to the power of 31 years. That is actually a little bit longer. But they also say that probably the proton will live forever. And there you also have a number then for eternity, forever. Just 1 zero more than the Himalayan analogy what we had. We also have, for example, that our sun's death will be within 10 to the power of 9 years. And at this time, this feather would probably just have eroded a small tiny part of the top of the Himalayas. One last comparison can be then to see that there is indeed something that outnumbers this eternity, and that is the number of atoms in the universe, which they have come up with a figure 10 to the power of 80. This analogy with the feather eroding the Himalayas is quite an eternity.
I spent years in the Himalayas, and one thing becomes obvious up there. These mountains feel eternal. They dominate everything. Weather systems, human ambition, ego, standing at altitude, time behaves differently. Days stretch, minutes dissolve. You stop thinking in schedules and start thinking in conditions. Can we move? Can we wait? Can we survive the night? The mountains doesn't care about your plans. They don't care about your legacy. They don't even care if you understand them. And yet they are temporary. Every ridge I've crossed is already being erased, not dramatically, patiently. Even defining where the Himalaya begins and ends is already a philosophical problem, which tells us something important. Eternity does not care about our categories. So, why does this matter? Because most of what drives modern life is built on the illusion of permanence. We behave as if civilizations are stable, resources are endless, growth can continue indefinitely, but nothing in nature works that way. Everything is on loan. The overview effect described by astronauts comes from seeing Earth as fragile. The mountain effects come from realizing that even the most solid things are transient. Eternity doesn't shout, it erodes. And when you understand that, urgency and humility suddenly coexist. You care more and you panic less. The feather will never erase the Himalayas, not really. The metaphor isn't about finishing the task, it's about recalibrating perspective. Eternity is not something we reach, it is something that dwarfs us. And paradoxically, that can be comforting. Your failures are small, your fears are brief, your existence matters precisely because it is temporary. The bird remembers, the feather keeps his promise, the mountains disappear, and somewhere inside that truth is a quiet invitation to act wisely, to care deeply, and to stop mistaking urgency for importance. If If this resonated with you, please like, subscribe, and share. It helps us keep asking the question that prevents us from sleepwalking into the future. See you soon.